Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. Other PLC sequencer functions. The keywords: the sequencer output, the sequencer input, the sequencer load, the ICMP input compare, a mask. Some PLC have DR functions, which include a mask features. Others have two additional sequencer functions, one that carry out bit comparisons and another which transfer output data sequentially into a register or a series of registers. Figure 19.14 shows the three sequencer functions of Allen-Bradley PLCs. This shows the three sequencer functions of Allen-Bradley: SQO, SQI, and SQL. This shows how the program looks like. This shows the controlling output, reference to detect completion of a step or a fault condition, creating the SQout or SQI file. This shows the mask, source, and destination. This shows the control. The sequencer output SQO functions is similar to the DR function described previously, but has a mask operation. The sequencer input SQI function sequentially matches the preset input pattern with the output pattern through a mask. The SQI output goes on if all designated bits matched. The sequencer load SQL functions capture reference using output bit patterns in sequential register or address each time the input is turned on. Figure 19.15 shows some of sequencer function of Multicom PLC. The drum sequencer function is essentially the same as the DR function described previously. The ICMP input compare function is essentially the same as the Allen-Bradley SQI function. The SCIF function is a combination of drum and the ICMP function. This picture shows the drum function. This picture shows the ICMP function. This picture shows the SCIF function. A cascading sequencer. The keywords: cascading sequencer, single function output capability, in parallel, Basic sequence functions have size limit. To optimal step, sequencer can be cascading. Some manufacturers designate this process as ch19. The single function output capability may be 8 or 16 bits wide, and 8 or 16 output terminals can control only up to 8 to 16 machines. If there are 29 machines to turn on and off, even a single 16-bit program will not work. To add more output capability, you must be change or expand the number of bits across. Some formats have a place in the program or an address register to expand the bit capability. When a code key or number is inserted, it will automatically expand the number of outputs. Other formats, such as the one shown in figure 19.16, must have parallel function programmed in. Figure 19.16 shows how 29 outputs can be controlled from a 16-bit function format. Two functions are run in parallel. The actual 13 bits are controlled by the second function block. This shows the expanded sequencer control for many outputs. We have two registers here. The other sequencer dimension may need more steps for a process than one program block contains. Sequencer can have 64, 128, 256, and other numbers of steps per program block, depending on the format and the PLC model. Suppose there is a 128 steps function limit for one basic function. If you need 227 steps, you must chain 3 functions together to run the process. 128 plus 128 plus 21 steps of the third function. Chaining is accomplished by starting the next sequencer after the last step of the previous one. A way to do this for one format is shown in figure 19.17. This figure shows expanded sequencer control for many steps. Exercise 1. The machine matrix, PLC sequencer program, manual, event actuated operation. Place the machine matrix shown in the figure 19.18 in a PLC sequencer program. Program for manual event actuated operation. This is the diagram for exercise 1, the machine matrix. Homework. Handwriting of keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.